Okay, I'd like to make some announcement quickly just for your information. So the most important thing is you have to make sure you complete lab 0. Okay, sorry. Lab 0. Okay, everybody should really get started. If you really got trouble, drop by my office hour 3 to 5 today. And also for Friday, you can also drop by the lab. I'll be there. There is a textbook over here, as I mentioned on Monday. I want to show you how you can get access to it. It's free, okay? But don't distribute it, okay? If you go to the course wiki site, okay? And again, if you're not enrolled, send me an email. I will add you to the access, okay? So once you log in, and then you have to click on SVN slides over here. Click on that. It's going to prompt you for login. In that case, you have to say 3311 followed by IFO, not your EECS login anymore. And then under readings, and the slides over here is for section Z, not for us, okay? Go under readings, and then you will see object-oriented software construction. So that is a PDF for you to obtain. Okay, download it, and you can start reading, okay? Apart from that, let's see, okay. Okay, that's about the textbook. And then I also uploaded 3 sets of slides just in case you got any trouble with the syntax for IFO. I'll just tell you briefly. We might refer to parts of them maybe later in the course, but not really today. Okay? I'll just show you where to go. If you go to my lectures page where I uploaded all the lecture recordings, you will see, number 1, decide by contract. That's what we're talking about right now. And then you will see here, you will see 2.1, 2.2, and 2.3. I would suggest have a look at 2.1 and 2.2 first. It talks about common syntax and common errors in IFO. I think that'll be useful to you when you do the exercise. It can save you time. Okay? For 2.3, it's about drawing design diagrams. I'll try to refer to parts of them as we go, okay, in the course. But 2.1 and 2.2. Okay? Okay, any questions in general about the course before I continue? All right. So what we said last time was about client-supplier contracts, and then now we talk about to be a good design, you want to make sure you actually guide your design by writing contracts, and the contracts should specify clearly what's the obligation and benefits between clients and supplier, okay? And the problem we are trying to solve, we'll continue to solve it and hopefully complete it. So starting from next Monday, we'll definitely do more course-related stuff. But this is also related. I want to just get you clarified with the various concepts. Okay, we talk about this particular bank account example. Just to remind you, what we focus on are 2 requirements here. We have bank accounts, and also each one of them has a balance that should be always positive. Okay, remember, always positive. And we may withdraw an integer amount from an account. Okay, that's what we started, how we started last time. And we actually talk about version 1. Let me just spend 1 or 2 minutes just bring you up to speed. What we did last time was to bring you version number 1. Okay? The problem for version number 1 is we discussed at least 3 problems. Number 1, you can see for the constructor over here for the account version 1, you can see the balance over here is never checked, so it might be negative. Okay? So for example, over here you can see in one scenario where, in OOP, you want to make sure every time you are trying to make a method call or trying to create an object, you're basically trying to invoke some client-supplier relationship. Okay? For example, over here, because we are trying to create a new object of type account v1, so we are really making use of the constructor for this particular class. That is why the context of calling this particular line is the clients. And on the other hand, this particular type is a supplier, right? That's what we talked about last time. And now in this case, since we're passing -10, so what you will do is you're simply just going to give -10 over here, and then you're simply just going to assign the balance to be -10. So that's wrong, because balance cannot be negative. Okay? That's the first scenario. And the second error we talk about is really about the amount for withdrawal. Okay? You can see, again, you're not really checking the input condition for the amount. It might be too large or it might be negative, right? Both cases, okay? So what we should really do is to have some precondition for the amount. I'll get a precondition in just 30 seconds. Let me just remind you again, how do you show the errors for these 2 scenarios? What you can see is for the first one, let's say we created an account with 100 initial balance. And then we are trying to, let's say, to withdraw. And this apparently is illegal, -1 million, right? But the current design actually allows that, because if you look at withdraw over here, if you simply pass 1 minus 1 million, it doesn't do any check, it will simply just do the subtraction. So that's why you will see no complaints, but you will just increase the balance for that account. So that's wrong behavior. Whenever there's any wrong behavior happening in your system, a good contract or a good design should catch that and report some error to you. So that's something we want to reach, at least in version 2. Okay. Finally, the last scenario, which we also went over last time. Okay, let me do that quickly. So now let's say we create initial balance 100, and then we are trying to withdraw. So again, this line here invokes client-supplier, right? Method call. And then we got 150. Apparently, you can see here, amount is being passed 100. And then the current balance, oh, sorry, let me say it again. Got something wrong. So first of all, this line is going to create an account with initial balance 100. So that means the balance over here is simply just 100, right? And then when you call this method here, it's going to be 150. So 150 over here, and then once you do the updates, it's going to tell you. So now after the withdrawal, you got minus 50. And this is again not acceptable according to the requirements, because it should always be positive. Okay? So what I have just demonstrated to you is a very useful technique. Whenever you want to criticize about your design or somebody else's design, the best way to do it is think about what's the problematic scenario and then show it. Okay? We'll do things like this throughout the course. Okay? Okay, so now we can move on to the new stuff. Okay? Before I present to you version 2, okay? We talked about preconditions last time. The easiest way to think about preconditions is it's more like under what circumstances can you serve. Okay? And this is basically the logical negation of exceptions. Exception, as you learn in Java, is more like under what circumstances should I signal an error. So that's kind of the opposite. Okay? However, it can be a nice approximation for precondition. Okay? But let's see. Okay, the precondition for this would be y should not be equal to 0, right? Only when y is not equal to 0 am I going to divide. This one easy. What should be the precondition for this? Yes. Yeah, I agree with you. Actually, we also did it. Okay. For those of you, I'm pretty sure every one of you took 2011. Let's say I want to do a topological sort of a graph. And by the way, this is topological sort. You will do that, I believe, in lab number 3. Okay. But since you took 2011, topological sort, what would be the precondition for this? Anybody? At least you heard of it, right? Ken. Yeah, so remember, have you heard about something called DAG? D-A-G. It has to be a directed acyclic graph. So that's the precondition, which means whenever you want to call this method topological sort on a graph, the graph itself better be, number 1, directed, number 2, it better be acyclic, no cycles. Okay. So the precondition must be checked before you call the method. So you want to make sure when you call the method, all the necessary input conditions is met. Okay? For example, let's say this. Let me just make the simplest example. If we did not have this particular precondition over here, so that means you always can divide. That's not good. Meaning that if I give you x being 10 and 1 being 0, how can you divide 10 by 0? You just get exception, right? You will just get error. That's not good. You should really signal an error before you try to do the computation. Okay, that's about the precondition. And in Java, the best way we can do is by encoding exceptions. Okay, so now you can see that the corresponding exception, for example, so now for the divide, the precondition, as we said in the previous slides, the precondition should be y is not equal to 0. But now, when you talk about exceptions, it's now y equals 0. So what's the general rule over here? Let me just mention that quickly, and then we can move on to the code. Okay? Again, you want to be very clear about what's the connection between exceptions versus precondition. Okay, we got precondition over here on one hand, and also we got exceptions on the other hand. Okay, so now think about preconditions like a service. And this is about error. Okay? Let's talk about divide as an example, but definitely apply for every one of them. So now let's say divide. Let's say I return the double over here, and then I got, I'll just say x and y, just assume they're double, okay, just to save my writing. X and y, and also double over here, and then divide x and y. Let's talk about these two different scenarios. We are basically trying to achieve something very similar. It's just that on one hand, we got precondition, which is conceptually easier to think of. On the other hand, on the right-hand side, that's the only thing you got in Java, like an exception. Okay? In the first case, if you have already started with lab 0, you should be familiar with this particular syntax called require. Require is for you to specify precondition. Okay? Yeah, that's a precondition. Now I can simply say only when y is not equal to 0 am I going to do division. If y happens to be 0, I'm going to give you some precondition violation. Okay, that's the first case. On the other hand, what we can do in Java is to take the logical negation of that, to say under what circumstances should you tell the error to the user. Okay, in that case, you will say something like this: if y equals 0, in that case, I'm going to say throw new illegal argument exception, etc. And then otherwise, I'll do the division, right? The two things. So using exception to approximate precondition is not too bad. It's just that it's a little bit detour you have to bear with, okay? But they're just logical negation of each other. So in general, if you have basically some Boolean condition B over here for the precondition, if you really want to simulate it in Java, what you would say is replace this by not B. Well, let me just put the programming notation, not B. Okay, you just cannot copy that verbatim. Okay, any question about this? The distinction between precondition and exception? Yeah. I would rather you think in this way. If the input value over here, definitely the supplier really should specify the precondition. I agree with you, right? Because for me to implement divide, I have to make some assumption. But let's say more about it at the runtime, right? If I try to do the following, if I say divide over here, and then I put 10, and then I put 0, okay? Now, in this case, 0 not equal to 0 is false. Agree? So that means this particular precondition is violated. So that means there will be some precondition error. In that case, who should be blamed for this error? The client, because the client passed 0, right? It is the client who makes this particular method call, divide 10, 0. So the client should have checked that they shouldn't really pass the 0 as the second arguments. Okay? So now in this case, what you will get is some precondition violation. In that case, it will be the client's fault. And in this case, client is simply the caller. The caller of this particular method, because they shouldn't pass 0 as the second arguments. Does that maybe answer your questions?
Well, I was just thinking back to the microwave problem.
Yes.
And if I remember the code correctly, for the code part of the supplier code, making a lot of assumptions.
Yeah. Yeah. So basically, talk about the microwave wave example. Let me talk about it very briefly. Okay. Remember the microwave example we talked about last time. Okay. So over here at one end, you got class microwave. And then you got things like a lock, you got things like a power, on. Whether it's lock or not, whether it's on or not, right? It's Boolean. And then you also got another method here called heat. And then it simply takes an objects. Okay? The reason that I omitted the code in the supplier side was because we haven't talked about how exactly you can encode the precondition. That's why I omitted that. But the supplier should specify the precondition somehow. Because when you actually call this heat method here, the client, the caller, should make sure whatever the assumption the supply is making must be met. Otherwise, I cannot provide the service. Okay? So now let's go a little bit further. The other side that we talk about, let me just bring this again, so maybe you can bring some insight to you. So now that you understand precondition better. Microwave user over here, okay? And then somewhere we got a main method, for example, doesn't matter, okay? And first of all, we declare microwave as a supply type, and then M. Okay, created. And then, so now, when I say M dot heat, and then let me just say objects, okay, obj. And of course, let me declare that so it will be self-contained. So objects obj is assigned to something, question mark over here. Okay, let's say that's it. Now, if you consider this particular method call over here, first of all, N is the supplier. The current objects microwave user is the clients. Let's say that's all we have got. Okay, it's slightly different from what I showed last time, so it's a slightly variance from last time. Okay, so now can you tell me that when I try to call this method here, should we even allow the body of the implementation for heat to be called? If you say no, why not? You don't know what the object is? I agree, it's for last time, definitely. Even more to that. Lock and on, exactly, right? Because I said this is slightly different. After creating the microwave to begin with, m.on will just be false by default. m.locked will also be false by default. If I did not explicitly, as a client, to make it on and also to lock it, in that case, I definitely cannot call the heat, right? So these are missing, okay? So now over here, calling this method should cause precondition violation. For on is actually false, and locked is also false, and obj is not guaranteed to be non-explosive. Non-explosive. Okay? Is that okay to you? When would these be checked? Yeah, so the client, so as long as the client try to check them, for example, one way you can fix it is by, okay, how can we fix it? Let's say I try to insert certain code over here. Okay, let me try. Okay, I can go things like this. First of all, I have to say m.lock. Okay, lock it, and also m.power. So now I can satisfy these two. But in order to satisfy this, let me do more. Okay, that's something I need to set in the slides. I can say if the objects I'm reading over here somehow is explosive, right? You may run some extra method to check it, right? It is explosive. In that case, I can do something here, okay? Otherwise, if it is not explosive, and now I can call this method. So I can say m.heat, and then obj. It's guaranteed. When I try to call this method here, the object is not explosive, right? That's one way to fix it. But the bottom line is, for you to call that method as a client, you have to make sure every precondition is met. But how do you know what a precondition is? You can look at the API for the method. Yeah, so basically the supplier's assumption is the microwave is locked, the power is on, and also the input lunchbox or whatever input object you put in should be non-explosive. It will be the client's responsibility, obligation to make sure they're all met. If any one of them is not met, it will be the client to blame. In that case, we don't even bother to call the body of implementation for the supplier, right? Yes?
So every exception is a violation of preconditions?
Aha. So for today, we're still talking about how you can use Java as a design language, right? We'll definitely get to IFO at some point. But as for today, yes, the way we signal a precondition error is by throwing in an exception. You will see that. Yeah, that's correct. Okay.
I say in this case, is it no longer necessary to implement exceptions
In over here, actually, I think over here, no, you should. You should. You're basically talking about what should we do to really encode the precondition? You should. Because if the client really gives you something that's actually not valid input, you want to make sure the supplier can actually deal with it and then to throw the exception accordingly. But we just didn't do that in the previous class because it's just an introduction. But now you will see it. Okay? Okay, if no more clarification needed, I will go on a little bit. Okay, so now let's talk about, okay, so this is basically summarizes to say precondition is not exactly the same as exceptions, but there's a logical negation of each other. Okay? It's approximation. So now let's move on to version 2. Version 2 will be very similar to version 1, except we want to prevent those three problematic scenarios from happening. How do we do that? Exceptions. Okay? Let's now do the following. Let me assume I already created an exception class called balance negative exception. Let's assume, okay? And then account version number 2, okay? We talk about second version. We say if the balance over here is less than 0, that means any clients who's trying to pass a negative balance, we should blame them by throwing an exception, okay? And then that's a scenario number 1. And to handle scenario number 2 and number 3, now look at the withdrawal over here. We say if the amount you're trying to withdraw, if that's negative, then you actually want to throw some exception. If somehow balance is less than amount, for example, if I got 100 as a balance, and I'm trying to withdraw 200, in that case, it should not be allowed. So that should be also like an exception to be thrown. Okay? I'll pause a little bit here. Okay, take a look at line number 5, 11, and 13, and make sure you're comfortable with it, so we can go on. Any question you want to ask, please. Now is the time.
The requirement was that was positive. I would just check that it's not negative.
Aha. So it seems to me your concern is about line number 13, correct?
5 and 13.
For 5, why would you think line number 5 is a problem?
Because if the balance is 0, it would be fine. But the exception, but it's not.
I agree with you. Okay, guys, do you see what the concern is? Okay, I'll briefly mention that. Okay, we'll fix one of them later. Let's say for line number 5, okay, we say if the balance is strictly less than 0, only that we're going to throw the exception for precondition violation, right? What if the balance is 0? If the balance is 0, let me give you a little bit simulation over here. Okay, so that is the version number 2, the same code. If the client simply give 0 as a balance, so now when you check for this particular condition over here, 0 less than 0 will be false, which means we don't throw the error. And then we simply just assign balance to be 0. The result of this would be we got an account with initial balance 0. Is this acceptable according to our requirements? Let me remind you, if you go back to our requirements over here, does it violate any one of them? Always positive, right? That's why I said before, you really want to formulate in your mind how to formulate these requirements. When we say always positive over here, that means it should be strictly larger than 0. Would you agree? Right? Rather than larger than or equal to 0. That's not the case, right? So now, if you actually got initial balance of 0, would that be acceptable? No. So that's good. Okay? So we are adding so somehow the mistake was intentional. So we want to do a little bit more later. Okay? That's good. It's good you pick it up. Okay, let me go a little bit further over here. Okay, again, let me just wipe it out. Okay? So it's clean. Guys, any question about 5, 11, and 13? And 13 has a similar issue, actually, right? But we'll get to that issue a little bit later. Can you see 13 is also an issue? Line number 13. This one is maybe a little bit trickier to think. What if? So you want to be sensitive to this kind of boundary cases, right? Okay. Let's say.
That would mean you could allow it a zero balance, right?
Exactly. So that's not good. That will, again, violate the requirements. Okay. Bear this in mind. For line number 13, we'll revisit this in just a moment. Okay. Keep that in mind. Yes.
But is withdrawing an amount of zero okay? Like, because it's not necessarily a negative amount. So.
I agree with you. So the question was, can we withdraw amount of 0? I would say the requirements over here was not so clear about it.
Yeah.
So I would say, in this case, we can assume that's okay. That's fine, just for this example, right? But of course, if the instruction says you should always withdraw a positive amount, in that case, yeah. Good. Okay, let me go back to version number 2. Okay, so now let's try to criticize it. So, okay, over here, so these conditions over here, number 1, number 2, and number 3. So these are the exception conditions. So they are just approximations for the intended preconditions. For example, if I want to see what's the corresponding precondition for this, I need to take a logical negation of that, right? Remember? Okay, so now I'll just do this one here. So now for this particular guy here, the corresponding precondition looks like this. Okay, that's how like a derivation process. It is not the case. Copy this exceptional condition, amount less than 0. Okay, would you agree this is equivalent to amount larger than or equal to 0? So what does that mean? That means this is the precondition, which is to say when amount is larger than or equal to 0, I'm willing to serve. Okay. So you can see the disadvantage of doing this in Java. You have to keep switching between error condition and also the actual precondition to really make sure they're consistent. So that could be one drawback, right? It would be very nice if, rather than specifying the negation of the surface condition all the time in Java, if we can specify the precondition right away without the negation, that'll be so convenient, right? That's one thing to note. Okay, any questions? Okay, I hope that's clear. Okay. Okay, that's about version number 2. So what I would like to do is, let me just go a little further. Okay, so now, why version 2 is now better than version number 1? Just go back to the scenario. Let me just run that very quickly with you. Okay, I kind of just put 2 sides so you can always see the client versus supplier. Okay, so now basically supplier is now version number 2. Okay, and then I'm going to run the 3 problematic scenarios as we saw from version number 1 and make sure every one of them is now okay in the sense that they are properly dealt with. There will be a precondition error. Okay, let's see how. Scenario number 1. Let's say in the client side, let me use green. That might be better. Red. This line over here, we are trying to create an account version number 2 with -10. So that means on the supplier side, we are supplying over here -10. And now, -10 less than 0 is going to be true. So that means we're going to throw the exception accordingly, right? So it's going to tell me illegal. So this is good. I'm trying to initialize my account with the initial negative balance, and it tells me there's an error. So that's good. Yes?
Oh, but it would allow a zero balance, though, right?
Yes, that's another error. We'll pick it up later. I'm just saying for this particular one, if you just got negative, it will be picked up nicely. Right? Good. Okay, let's go to the second scenario. The second scenario by the way, can you just take a look over here? Okay, that's a client's code. Did you realize now the client code becomes more complicated? The supplier over here potentially might throw. Okay, first of all, let's see this. I'll tell you precisely what I meant by this. First of all, we are trying to call this particular constructor over here, and also we are calling this particular method over here in the client side. Java tells you if the method you're trying to call may throw some exception, either you have to catch it, or you have to specify as part of the method over here to say you might also throw it, right? The catch will specify requirements in Java, okay? I'm just telling you, okay? So now, if you look at the supplier side, potentially we might throw balance negative exception. And when you call the withdraw method, you might also throw withdraw amount negative exception. You might also throw withdraw amount too large exception. Since potentially I might get 3 possible exceptions, for any clients to call these 2 methods, they have to try and catch them. In some way, we are polluting the client's code. So that means it makes the writing of the code for the clients more like harder. Okay? It would be very nice if we don't have to write such try and catch block. It would be very nice, right? Okay, let's now go over a little bit over here. First of all, we got 100 over here, okay? So now 100 is going to be fine. So we're just simply going to set the balance to be 100. So now when we say withdraw minus a million over here, right? So now, so that means when you try to withdraw minus a million, so now amount less than 0, is that true? It is true, right? So that means this particular exceptional condition is true. So that means we're going to throw this withdraw amount negative exception accordingly. So that means the control flow is going to be broken, and then we are simply just going to go to this particular catch block, and then we're going to throw the error. Okay? So this again shows that version number 2 is better than version number 1, because when there is an illegal value for the input, we simply wouldn't do the corresponding action. We'll just give you an error. Okay? Okay, any questions? Okay, final one to run. Final one. And then we talk about there's also some drawback for version 2, even though improve all the drawback from version 1. Okay? Okay, the third one over here, let's say this. Again, we try to create an account positive amount, balance 100. And then we try to withdraw 150, right? Apparently, this should not be allowed. There should be a precondition violation conceptually. Okay? Let's see if the corresponding exception will be thrown. When we call this withdraw over here, at this point, the balance has been set to 100. Okay? Let's just make a note. The balance is simply just 100. And then we are trying to withdraw 150. Okay? So now, let's try to run. Will this error condition be true? No, because amount is simply 150. Less than 0? No. Simply means this particular error does not occur. And then we move on to the else if part. So now we got balance, which is 100, right? Remember the 100 here, right? That's how we created the account. And then the amount we're trying to withdraw is 150. So now, is this error condition true? It is. So that means we are going to throw this particular exception at the runtime. And what that will do is it's going to be broken, and then you will go to this particular catch block. Withdraw amount too large exception. So that's also good, because when you're trying to withdraw something that's too large, it'll give you error, rather than just doing it. Don't lose the big picture, okay? The code already looks a little bit complicated, sophisticated to understand. The way I move on from version 1 to version number 2 is by introducing 3 kinds of error condition, like exceptions. And then I simply encode every one of them into the if conditional. So you will know that when the input value does not satisfy any one of them, we're going to throw the corresponding exception. Okay? Now, we have to now criticize on version number 2 a little bit more. Okay? It's resolved all the issues from version number 1, but it's not perfect. Definitely not. Okay? We still got quite a bit to go. Let me go back to the slides. Okay? Everything has been set already. So now what I want to do, okay, so this is actually a very important statement over here. Because we have added precondition or like an exception to the Java code on the supplier side. So now the client side has to do all the catch statements, which pollute their code quite a bit. Just make it more complicated for your clients, which is not good. Okay. Okay. So now let me go on to this slide here. Okay. As you pointed out, I agree. Line number 5 is not accurate because when balance is actually 0, we shouldn't allow it. Okay, let's understand that error, okay? But let me do another one which is similar, okay? If you look at line number 13 over here, okay, we briefly discussed it. So now, would you agree that one is also problematic? It only requires that the amount you're trying to withdraw is strictly larger than the balance. But what if it's just equal to? If I got $100, I want to withdraw 100. It should be allowed or should not be allowed? Should not be. Should not be allowed because the consequence would be you just got 0 balance, right? Good. So now let's illustrate this. Okay, that's exactly what I just said. So now what I would like to do, just do a very simple scenario. Okay. So now let's go to the next one here. Okay, basically scenario here, let me go to iPad here. Okay, again, we got client, we got supplier, right? Okay, let's do this quickly. We created an account 100, okay? And then we are trying to withdraw 100. When we first call this gym.withdraw, okay? So first of all, after this particular line, okay, we know that for the account, the balance will just be 100, okay? And then when we call withdraw over here, and the amount is also 100. So now we want to know if version number 2 is going to give us an error when we try this. No, because when we check this, first of all, 100 from here, less than 0, false. So we don't throw that error, right? So this one is bypassed. What about the else if condition? It's also going to be false. Because the balance, as I said, is going to be 100, right? It's been set up. And the amount over here is also 100. 100 less than 100? False. So that means we also bypass this particular error code. And then we'll simply just do this the balance is assigned to this the balance minus amount. So that will give us 0. Everything will just seem to be normal. But that's not right. Because something has gone wrong. You have just resulted a balance with 0 balance, which violates the requirements. So for this slide here, I'm just demonstrating why version 2 is not perfect, just not there yet. Because somehow the precondition you have allows certain input value that should not be allowed. For example, when the balance and the amount are equal. How can we resolve this? Okay. Well, of course, one way to resolve it, I can say less than or equal to. That's one way. That's not a problem. I agree with you. However, I would like to, okay, let's say that's solution number 1. I would like to talk about solution number 2, okay? This is solution number 1. I would like to talk about, let's say I don't want to fix it. Is it possible to actually have more like a safety net for the entire object so that anytime if I have any negative balance of the account, I'm going to give you a counter violation. Is it possible? Okay. So now I want to introduce a new concept. It's called class invariants. Okay. So now we are done with precondition. Okay. So now I want to introduce another concept called class invariants. Let me just go through the slides, and then we'll do more illustration. Okay. Okay, so here talk about the, we need to fix it because we got missing case, right, from version number 2. Okay, how can we fix it? So now we want to say we don't want to fix that precondition per se. Okay, we want to do something else. We want to consider the following. Okay, let me just give you a little bit idea. Okay, to say what we're going to do here. The second concept we're going to talk about is a kind of contract that's called class invariants. Invariant simply means something that does not change. Class invariant is going to be a condition which can be evaluated at runtime to be either true or false. Okay? And then for the class invariant to be valid, we want it to be evaluated to true always. That's what we wanted to happen. Okay? What's a class invariance? Basically, is a property that holds true for all objects of a particular class. Okay? For example, if you talk about the account class, you want to think about what's really for every account to really exist at the runtime. What should be the property it should hold true always? After deposit, after withdrawal, right? You want to have some invariance over there. Well, in this case, according to requirement number 1, it should always be positive, right? So now, in this case, we want to have a class invariance over here. To make it informal, you want to say the balance should be strictly larger than 0. Okay? That's a balance. Okay? Let me give you a little bit more intuition here. Thinking this way, let me use like state diagram for you. Let's say after you have created an account objects with some initial balance, maybe it's simply just 10. Initial balance is 10, okay? And now you can think about all the transition we are trying to do in order to move on is by calling a method. For example, if I say withdraw 5, for example, in that case, the resulting balance should be 5. And if I want to say deposit, it's not really here, but I'll just mention that intuitively. If I say deposit 100, and then that'll be 105, etc. Right? Conceptually, think about every method call we are calling on the objects is like a transition, and the state is more like a combination of the values for attributes. Okay? What's invariance? Invariant really is you want to check to see if the invariant property is satisfied for every state for the runtime. As soon as you have a state of the objects that does not satisfy the invariance, then you should really give an error right away. For example, let's say after 105, let's say now I want to say withdraw 200. In that case, if I simply try to do it, that would just be minus 95, for example, right? In that case, minus 95, does it satisfy balance larger than 0? It doesn't. So that would be an invariant violation. So think of invariant as a very like a global property for the class, which means every object you're trying to create from the class must satisfy this property always, after every subsequent method call. Okay? It should always be the case. If after any method call, the invariant property is not satisfied anymore, you should really give a class invariant violation. Okay? Any question about what I have said so far? Concept about class invariance and this particular example for account. We'll do more examples. Okay? Let's now do a little bit more. Okay? I do have another example for you, 1 or 2, I forgot. Okay. Invariance is basically, okay, as I said, it's going to be a precise, when I say precise condition, that means it's going to be a Boolean condition. Okay? Let's say you have a class called CS major students, right? Like you guys. What would be the invariance? Invariant in the sense that as soon as you end up in a state that does not satisfy the class invariance, you're in trouble. What attributes would you have for you as a student? Maybe the courses you are registered, or maybe GPA, right? What would be the invariance for you in terms of GPA? Yeah. Well, are you sure only greater than 0? Can you ever get to?
You can. You can have really bad GPA.
Yeah, you definitely can. Yeah, sure. I'm pretty sure the school will warn you even before you get to 0, right? Yeah. What's the minimum GPA you have? 4.5? Yeah, I agree. Okay, so would you agree the corresponding class invariant will just be GPA larger than or equal to 4.5? You see my point here? I'm not talking about programming. I'm just trying to give you some intuition about class invariants. Class invariants should be applicable to every object you can create for that particular class. Having this in mind, let's have a slightly more complicated case. Let's say you have a class called binary search tree. Conceptually, it's a tree, right? It's binary. It should really satisfy a certain property. So now, that property you are thinking about should be the class invariance. Whatever class invariant you're going to tell me is going to be applicable to every legal instance of binary search tree. As soon as that class invariant is violated, you should give me a class invariant violation. Guys, any idea? What should be the class invariant for binary search tree? Jordan.
So the number of nodes should be non-negative?
The number of nodes, yeah, I agree. So you should, yeah, I sure, no problem. Anything else?
If the number you are searching is less than
The minimum value?
because it's binary search tree.
Yeah.
Because the number input, if it is less than the root, you go to the left.
What you're describing is how to do binary search. That's not really a predicate. Whenever I talk about class invariant, it's a Boolean predicates. So what I really want is a predicate condition. Yeah.
So for each node, there should be 2 or less child.
Okay, you basically talk about binary part, right? You basically talk about invariant. Okay, let me write it down. It's okay.
But it has to be acyclical. Like acyclical graph.
Tree by definition is not acyclic, right? It's actually acyclic. Okay, so now we talk about, okay, let's think about this, right? We want to talk about class invariants for binary search tree. What you just said to me was, you want to make sure every node has at most 2 children, right? Okay, I agree. If I have a tree of this shape, it's a guarantee to be a binary search tree. Well, there's only a single definition for binary search tree, right? Okay, just bear with me. Okay, anyone? Anyone want to speak up? Yes. What should be sorted? Well, if you say binary search tree should be sorted, it's kind of a little bit vague. I want a little bit more precise definition. Yeah. Okay, that's a little bit better. For example, if I got, for example, let's say this, 3, 5, 1, 4, 6, 10. Is this a binary search tree? It's definitely not. For example, you can see over here, for this particular subtree over here, right? You can see its left subtree is less. Its right subtree is actually not more, right? That's not a binary search tree. Okay? You're violating a search property. However, how can you be a little bit more precise about how to check this? I agree with you, the search property, that's not a problem. Okay? Jordan.
So just for each node, if its children exist, its right child is greater than its value or equal to
Yeah,
it if you're
I agree. I agree. Yeah.
its left child
Yeah,
less than
I agree. So what Jordan just said, I will take that as a version number 1. I do have another version. Okay, I'll talk about both. Okay, just for your information. One way to do it is by, for example, you can implement a method by yourself. Let's say Boolean. Let's say is BST. Okay. And then you simply take a node. And then you would say something like, if the left exists, in that case, the node somehow must be, the left must be less than the node, right? If the right-hand side actually exists, then the right-hand side must be larger than the node. And I'm not completing this, but it should be somehow recursive definition.
So in each of those, you should also
Exactly. Yeah. For example, you may want to make sure at the end, you also want to make sure also is BST the left, right? Something like that. I agree. Okay. I have another version for you. Okay. I'll give you a hint. Do you know the in-order traversal? If it's a binary search tree and I do an in-order traversal, what should be the property on the result? Yep, exactly. Yeah. That's the version I put on the slides, but I'll just give you both. Okay. So now the class invariants, the version I have is if you try to do an in-order traversal on the binary search tree, the resulting sequence should be sorted. Okay, that's class invariance. Okay. Class invariance is a very important notion which you are not so used to from the previous courses, but it's quite absolutely critical for this course. Okay. Any clarification you need on the class invariance? Yeah, there's at what point you actually check for each contract, and we're not getting there just yet. Think about for the precondition, you check the precondition before you try to run the method, right? Just check the input. For the class invariant, you can think about you only check the class invariance when you have done some updates to your method. You want to make sure whatever update you have just performed does not cause does not cause your object to be invalid. Okay, that's class invariance. The class invariant should always be maintained true. And when you check it, you want to make sure every time you do any changes to your objects, you should check the class invariant to make sure it still holds true. Okay. Yeah? It's a very good question you're asking. So what you're asking is, let's say I have a tree of 1 million nodes, let's say. Okay, it's realistic. And then if the class invariant has to be checked for every update, number one, for sure, it will not be efficient. I agree. However, number two is important. Okay, if you have done lab 0 preparation material, at some point there is a functionality called finalize. Finalize simply means now I'm ready to deliver my projects to my clients. When you say finalize in IFO, okay, I'll talk a little bit about IFO. In that case, you turn off all the contract checking, which means, okay, let me give you a little bit idea over here. What you're asking is absolutely legitimate, okay? Number one, when the data structure is large, checking contracts, for example, class invariants, and also postcondition as well later when we talk about it. Class invariance is inefficient. Let's understand that first. Just take the example for the binary search tree. If you have to check your 1 million node binary search tree is in the sorted order for every update, it's very inefficient. Okay, number one. Okay, number two, you have to understand the following. Okay. Conceptually, think about this boundary here is about your development space, which is 100% internal to you as developer. Okay, you may have so many versions of your system, version 1 to version 2, all the way to maybe version 100, upon which you're happy for delivering your software, right? And now you can now deliver the finalized version. Okay. Everybody happy with this so far? Okay. So let me just mention once more and then I'll talk about. So this final thing is really to build an executable for your system. So this is finalize. Okay. So this is the version where all the contract checking is turned off. So this will effectively solve the efficiency issue you talk about, because in the final version of binary search tree that you deliver to your customer, whenever they run it at the runtime, the invariant will not be checked anymore because they're turned off. The follow-up question would be, if it's going to be turned off, why do you specify that in the first place? Agree? Okay, that's a follow-up question. I agree. Over here, in all the version that's internal to your developments, we argue that in all the internal version over here, contracts are necessary to guide the developments, even though they are inefficient, but they are beneficial for you to actually strike a balance between obligation and benefits between the methods, so they should be there. I'll try to give you guys maybe another small example. I did prepare one last semester. I didn't present it in this class. I'll do it next time. Okay? So guys, what I want you to realize is the orange and the red. Okay? Orange is everything before you submit your software products for grading or for delivery, right? In the orange part, you really want to use contract checking to really help you to see if the input, if any illegal input can be accepted where it shouldn't be. That would be precondition. Or if there's any object you might create at the runtime that might give you invalid states, that'll be class invariants. The orange part, you should really get contract checking, even though it's not efficient. We are trading time for correctness. Are necessary to guide your developments, okay? So we are basically trading time, which means contract checking is inefficient. Trading time for correctness. Because we want to result in a correct design, okay? But when you are happy in the final version that you have eventually, before deliver, you want to make sure the performance bottleneck does not occur to your clients. So you want to finalize it. So in the final version, nobody will do the contract checking. But before that, you want to make sure you do it. Okay. Yes? Yeah, so before the final version here, you can see, that's why I draw the box over here. Let me just emphasize it again. You can think about the green one over here. So this is a boundary where it's internal to you as a developer. You want to make sure within this boundary over here, you may have as many versions of your development as necessary. All of them should be subject to contract checking. Contract checking has the advantage of making sure you can outline the obligation and benefits of your client supplier nicely.
But I mean, the contract checking is it so that we just need to check the class environment at the final step. So
oh, no. You should really check. So here are just different versions, right? So for version 1, it's like a version 1 for our bank account. For version number 2, you also got version number 2 for your bank account. For each version, you want to make sure every time you test you run your system, you should really run your check your invariant for every update. You know what? Hold that question a little bit, because we'll definitely make it precise as to how to check the class invariant. We'll get there. Okay. Okay, guys, any other questions? Yes.
For contract checking, you mean all the precondition, postcondition, and class invariant?
Yes. So there will be 3 contracts we'll talk about: precondition, postcondition, and class invariants. Right. So far we talk about precondition and class invariants. Right.
Yeah, but you mean in the finalize, when you want it, you just turn it off, but they are still there, right?
They are still there, but it will just not be checked at the runtime.
But when you release the delivery, otherwise, the input is viable in the precondition.
Okay. So I would say, okay, I will definitely give you that particular small example I have. Okay, I will do that on Monday. Okay, but today at least I can finish all the kinds of contract today and talk about a little bit about runtime checking, and then I'll promise I'll start with on Monday about why you need a contract to guide your developments. Hopefully that'll make it clearer. Okay, I'll get there on Monday. Okay. Okay, good. Okay, let me go back here. Okay, how can we encode class invariant in Java? Let me go there quickly. Okay. So now one way to do it is by using assertions. Okay, because think about when you should really insert this particular class invariant to check it. Okay, let me just tell you for version number 3. Okay, so now we're going to introduce class invariants. Let's see how we can do it. Okay, for example, You might say for the CS major students, assert this.GPA larger than or equal to 4.5, and for binary search tree, also assert. The good thing about using assertion is you don't have to negate that particular condition, right? You can just say, I want this to be true, okay? But now, where should we insert them? What I want you to do is to think about, before I show you version number 3, what I want to do is, I want to ask you this. Okay? Okay, it's a little bit messy over here, so what I will do is, I will copy the version 2 over here, and then you can help me a little bit. Okay? Okay? In order for me to evolve from version 2 to version 3, okay, again, this is version 2, there's no class invariance. So now, apparently, what I really want is to insert some assert. For example, balance strictly larger than 0, okay? This is my class invariance. So here's my question for you. Where should I insert this assertion? Would there be a single place or multiple places? Basically, the difference you will see between version 2 and version 3 will be you will just have a bunch of more assertions. But I want to think about where to insert them. Yes?
It would be right up to the methods call. So after here, since the balance would be among the next notation, if the balance becomes 0, you can assert right up to the line 15.
Only after line number 15?
And also,
Remember we are talking about supplier right now, right? We're not talking about clients. Okay? So now you're saying that we should insert the assert over here after line 15. Okay? So that means whatever basically after you have assigned the balance to be this new value over here, we should really say assert. The balance should be larger than 0. That'll be one place. Is that the only place? Would that be enough? Remember I said invariant must be true after every update. Is this the only updates you might have? After line 7? Yep, exactly. Because now we only got 2 methods over here. You have the constructor, you have the mutator over here. I would say typically, if you know the method might modify the attribute somehow, you should check the invariance. That's a general principle. Okay? So now we have to repeat this particular invariance and insert it here to say assert larger than 0. The same class invariance has been inserted manually twice in different methods. Do you see that? What's the disadvantage for that? There is something which we'll definitely talk about a lot, a design principle called single choice principle. I'll just mention that. Okay, we'll see a lot of that later. Single choice principle. Single choice principle says the following. If there's any change you want to make to your system, you should really make that particular change in either a single place or the minimum number of places. That's why it's called single choice. Basically, you want to avoid redundancy in your design. Okay, I'll give you one example. In this case, in Java, it definitely works because we're encoding the class invariance assertion and inserting in the right places, even though it's multiple places. But now, let's say this. If somehow I change my requirements so that I allowed the balance to be 0. Let's say I allow that. Okay, so that means now the assertion I want to have is larger than or equal to 0. So now, since my requirement changes, I have to change my design. How many places in my design should I change? Would it be just a single one? No. I have to manually go to here, change that to be larger than or equal to, manually go to here and change that to larger than or equal to. So that violates the single choice principle because there's a single class invariant, but somehow they have been duplicated redundantly in multiple places. That's not a good design principle. So having class invariant the way we do it in Java, it might work only at the implementation level, but it's not a good design. Okay? So it'll be so nice if we can declare the class invariant in a single place, right? So that's the case in iPhone, but we'll see that. Okay, so now let's go to version number 3. Okay, version number 3, exactly what I just said. So we insert the 2 assertions, even though they violate the single choice principle. That's okay. Let's live with them for now. Okay, let me just demonstrate to you, and then it's very important for me to take another, roughly, I wouldn't run over time, don't worry, about 10 minutes or so. Okay, I definitely want to go to this guy here. Okay, this is good. So now we got a class invariant, right? There's a class invariance. Class invariant. Later, towards the end of the course, we talk about another thing called loop invariance. Don't get confused. We only talk about it towards the end, but not only focus on class invariance. Why is this version number 3 better? Let's just see very quickly, okay? So now again, we got client, we got supplier. So now let's talk about it quickly, okay? So now let's say this. Again, we created an account over here. Initial balance is simply 100. So balance is now 100, okay? Well, think about conceptually, we have an object after creation. The balance is simply 100, okay? And now we are trying to call the withdraw method. So we are calling withdraw. Okay, and then withdraw is 100 over here, and then when we call the withdraw over here, the amount over here is 100. Okay, as we went over before, this particular error condition will just be false, right? So we're going to bypass. And this particular error condition will just be also false, right? Because 100 less than 100 is also false. So now that means we go to the else part, and then we'll simply do this particular check, this particular assignment, the updates, okay? So that means it's going to do 100 minus 100. So that means we got 0. And now the principle of checking class invariance is to check it upon the termination for every updates. So now when we check it, are we going to pass this particular assertion? No, because now this .get balance will just give you 0. 0 larger than 0 will give you false. So you actually get assertion violation. So this is an improvement from version number 3. Yeah. We're exactly doing class invariant over here. The class invariant should be checked upon the termination for every updates. That's exactly what we're doing. Okay. Okay. Guys, any questions about this? Okay, I said something. Sorry, I made a slight mistake. So this is version number 3. It's an improvement from version number 2. Okay, just in case you got a little bit confused. Okay. Okay, so now this is good, but now we're going to talk about why this version may not be so good. Oh, you want to ask a question? Go ahead. Yeah. Oh, when I say get rid of checking, yes, there's an option there in iPhone Studio to actually say, I want to turn off the contract checking. But all the contract you have specified in your programming text, they're still there. They just wouldn't be checked at the runtime.
Right, but then if we're checking, how would we add these type of errors where it's
It's a good question. So let me address this. Maybe I promise I'll address this on Monday using an example. If I not just talk out verbally, you may just get very confused, right? Yeah, I'll get there on Monday. Okay. It's a valid question for sure.
these assertions will be turned off in the final.
Yes, that's correct. But of course, now we'll talk about Java. There's no finalized version, right? I'm talking about just concept right now. Good. Okay, so now, guys, for version number 3, it's still not good. There's a very serious flaw in version number 3 still. Okay, consider the following. Let's say the amount we are trying to give for withdrawal is neither negative nor too large, which means we make sure we only give positive amount, and also we give something that's affordable. Now, So that means we fully specify the obligation for the clients to say if the client wants to withdraw, make sure the amount is not negative, also the amount is not too large. So these are all obligation of the clients. However, the contract must be fair. If you have set all the obligation about the clients, did we say anything about the obligation for the supplier, for the withdrawal itself? Let me ask you this, okay? If I'm the supplier, okay, so now I'm imposing all the constraint on my potential clients, I will be very happy because, so now the only place, the else part over here, think about the else part here. The else part over here is where the service is provided. And in this case, you have a very, very nice and smart supplier. They did the correct thing. They know that if you want to withdraw, you better use subtraction. But what if you have an evil supplier? They know that all the preconditions constrained upon the clients have been satisfied, but they do something useless, or they do something incomplete, or they do something that's completely wrong. Show you one example right away. You see my question here, right? My concern is we are being unfair. We put so many constraints on the clients, we put nothing on the burden of the supplier. That's not fair. It's like you are the user of the binary search. I require you as a supplier to say the input sequence should be sorted. But you give me a sorted sequence, I only give you a printout of hello world to the console. There will be nothing blaming on me. Nothing. That's a problem, okay? Let me use this example to show you. Okay, let's take a look at this, okay? Nothing has been changed, so now for version number 4, the only thing that has been changed is as follows, okay? Only this line over here, again, this is the else part, so precondition hasn't changed, and processing invariant hasn't changed, right? Everything's the same. So now this is the wrong implementation of the service. And then you're saying plus. I want to withdraw, you say plus. Oh, you want to withdraw, I say plus. Will I be blamed according to the current design? Okay? Anybody? I'm definitely going to show you, this is important, but try to see if you can answer me before I show you the concrete example. My question is as follows. Do you think, according to the current design, right, the supplier, like me, I'm doing something completely wrong. Will I be blamed for doing something wrong? For example, let's say here, let's say you got 100, right, in the account, and then you say, I want to withdraw $50. What I will do is, I will actually add $50 to your account. It's nice, but it's wrong, right? So now, will there be any error reported to this wrong thing? No, because the only check we have is the assertion at line number 10. Line number 10 over there, I simply say, okay, the only thing check is make sure it's positive. With 100 increased to 150, 150 is still positive, nothing wrong. Okay, let me demonstrate this, it's really important. And then I'll spend about 5 minutes to talk about how you can encode such postcondition, okay? Let's say this. Again, we have this, so now we talk about version 4. We're getting very, very close to version number 5, very close, okay? So now you can see for version number 4, so this is a wrong implementation, okay? Let's see what's gonna happen here. What I want to demonstrate is at the end of the call, the supplier, even doing something wrong, is not going to be blamed. Bank app, there's a client. So I created an account of initial balance 100, okay? And then I say I want to withdraw 50. So now the amount to withdraw is simply 50 over here. And then, okay, none of the error condition will be satisfied, so I'm bypassing them as before. Okay, so now what I will do is I'm going to say this the balance is assigned to this the balance plus the amount. So that means it's going to move from 100 to 150. Agree? That's apparently wrong. But when I check for this particular class invariant to make sure every resulting balance is actually positive, am I going to violate the class invariance? No, because now get balance will just be 150. 150 larger than 0 will be true, so I'm okay. It doesn't really mean the class invariant is wrong. I'm just saying there's something missing over here. The class invariant is just to ensure every object has certain property satisfied upon the updates. However, the problem over here is there's some missing obligation for the supplier. That's the problem. Okay? Let me just take 2 minutes. Okay? Just take 2 minutes. Any idea how I can specify the obligation for the supplier? I'll give you a little bit of hints over here. Specifying the so-called obligation for supplier is called postcondition. And the tricky thing about the postcondition is you have to worry about when I go from when I say, let's say this, when I say some account dot withdraw some particular amount, A, okay? Upon the termination for this particular method over here, I have my balance to be something, okay? In order to me to completely specify what should be done by the withdrawal, I somehow have to compare the value in the pre-states, right? Remember we talked about pre-states, right? And also, the same attributes should also have another value, let's call A. And after the withdrawal, the value is B. The post-condition, the idea really is, I want to specify some relationship between A and B. What should they be? Oh, you know what? I shouldn't call it A. That would be confusing. Can I just call that, if you allow me, X and Y? The balance value before the withdrawal, let's call it X. The balance after the withdrawal, let's call it Y. And the amount to withdraw is A. And post-condition, which can be used to constrain the supplier, should be a relationship between pre-states, post-states, and input value. What kind of Boolean predicate can I write about this post-condition here? Exactly, exactly. Y is equal to, mathematical equality, is equal to X minus A. Agree? Conceptually, you're good. However, how do we encode this postcondition in Java? The problem really is, when I already reach this point, after the execution for withdrawal, the old value in the pre-state for balance is lost. It's been overwritten already. So I'm already hinting how you are supposed to implement this. Any idea? A temp value to save the value in the pre-states, exactly. Okay? Let me show you this, and then we are done. Okay? Just bear with me just 1 more minute. Okay? Version number 5. Okay? Basically, you can see in the withdrawal method over here. So now we are saying that in the beginning of that, we just have a temporary value. I call it O balance to make it more meaningful. And then I simply save the balance to be there. And then after the updates over here, so this is the wrong surface over here. After this, I simply say another thing, which is so-called a post-condition. Okay? The post-condition over here is saying the following. It's saying this get balance, this is the new value after the withdrawal. And it should be exactly O balance minus amount. Can you see that? What's the drawback for this? The drawback is this is a very easy postcondition. You can see that you have to manually encode the old version of all the attribute that's relevant. When the postcondition involves maybe 5 attributes, you have to encode 5 temporary variables in the beginning, right? Not so convenient. It would be so nice if we have a built-in syntactic notation to say I can refer to the old value for the attributes automatically. Okay? One more thing, and then I'll let you go. This is what you have to do in Java, right? Later on in IVO, all you got to say is you have something called ensure, right? I'm sure everybody have seen this keyword already in short as a postcondition. All you gotta say is balance over here equals, for equality, old balance, O is a keyword, minus the amount. Okay? Okay, I will pause over here and then I'll resume next Monday. See you next week.